not sure exactly. We'll see if that comes up. I've got Jill Tarter here, and Jill is patiently waiting for me to tell her that the stream is working, but I don't see that the stream is actually working.
Oh, I'm glad somebody else has problems.
Yeah, it's not only SETI researchers that have trouble. Oh, no, we're live. Awesome.
Oh, good.
Great. Let me make sure I have a voice here. Awesome. It's working. Anyway, I'm happy. You're happy. Jill Tarter, you're a legend. You're an inspiration to me. You endorsed my piece of writing here called Losing the Nobel Prize, and I was super proud to have your endorsement. It means so much to me. Where are you joining us from today, Jill?
Oh, I'm locked down in Berkeley, right, as I have been since March.
Where else would we be if not locked down here in the lovely state of California? So I thought today it would be wonderful to have a conversation with you about your career, but also about all sorts of interesting questions from our guests. But the first thing I want to ask is, of course, everybody, it's burning on everybody's mind. Do you believe in Santa Claus, Jill?
This year, Santa's got a lot to live up to, right?
That's right. But the real question is, do you believe in that some sort of intelligence is living or might be living near the star system known as Proxima Centauri b and providing us with techno-signatures?
Yeah. Well, first of all, the verb believe is the wrong verb.
Yes.
Because it doesn't matter what I believe, what you believe. It's what is, right? And so this is a scientific exploration to try and find evidence of someone else's technology. And in my case, the Proxima B story is a bit frustrating, right? It never should have been made public. The observations were done in a way that is problematic in the sense that they did not have a second simultaneous observing capability. They didn't have, it was actually somebody else's data looking at something else. And so the ability to have any kind of validation, confirmation just wasn't there. And, you know, I like to say that if I'd been running the show at Ohio State, you never would have heard about the wow signal because the scientists had set up a certain protocol, certain criteria that a signal had to satisfy in order to be potentially a candidate. And the wow signal, though stronger than anything they'd heard, did not, in fact, fulfill those criteria. So you got to be willing to say, nope.
That's right.
Yeah.
So, but yes, the wow signal kind of does, dog the field. And I've always wondered, why do people put so much credibility in that wow signal? It was sort of one night only, and again, yes, it's not about belief. We have evidence.
Seconds only.
Yeah, it was like one 7-second period.
72.
72 seconds, yes. And it was never repeated again. Now, it doesn't rule it out, but as you say, we look for evidence. We are observationalists. And I've been having a lot of conversations on my channel with Nobel laureates and other esteemed guests. And, at varying degrees, people do in science have some strong amounts of faith. It surprises me how much faith people have, including things that maybe in principle can't be proven, like singularities, like multiple universes. And so I've always wondered, when you do the work that you do, you've always done it quantitatively, and you look for evidence. But is there at any point, people say, what do you hope to discover? How do you react to that? Again, it's not about belief, but surely you must, as a human being, although scientists, we always say an outgoing scientist is one who looks at your shoes when he talks to you or she talks to you. But anyway, as a human being, what would it mean to discover this? Why is there so much interest in this particular signal and in the field of SETI in general?
Well, the thing that we're interested in most is ourselves, right? That's what people want to talk about and think about, is ourselves. And in this case, what we're trying to do is figure out how we fit into the cosmos. What is our place in the universe? So I think that's what intrigues people. And there are all kinds of possibilities. So perhaps we will discover another intelligent technological species out there. And statistically, they're going to be older than we are. Right? And the question of how you become an old, stable technological civilization is a very interesting one, because we're in this adolescent phase, right? And it's not clear that we have a long future. Mm-hmm. But the detection of a signal would show us that it is possible to have a long future. Someone else made it through. And the reason that we can guarantee with a single detection that that we're talking about a long future is the fact that in order to make a detection, two technological civilizations have to be close to one another, close spatially and overlapping in time, cotemporal. Mm-hmm. And in a 10 billion year history of this galaxy, the only way that it's likely that two technological civilizations are going to be around at the same time is if they persist for a long time, in cosmic times, not in human times. And so we can have certain confidence that any signal we detect is going to be coming from a long-lived civilization, and just the proof that it's possible to get there from where we are today, it seems to me incredibly important and hopeful.
Yeah. When I heard recently, I had on Sarah Seeger from MIT discussing phosphine on Venus. How did you react to that? I haven't talked to you about that since that announcement and the subsequent sort of controversy that's erupted from it. I do have an invitation, I should say, to Jane Greaves, who's the lead author of the study. She's hopefully going to come on early next year. But how did you react? Personally, were you? Are there things you'd like to see? I mean, I'm happy to put in a word with Sarah and Jane.
Well, when I saw that, I thought, okay. So here there are two questions. Did they get the right line? Because it was a single line identification. So usually when we study molecules in the interstellar medium and we're looking for new species, you require multiple transitions to be detected. This is a single transition. And secondly, are we so sure that we have exhausted all the possibilities in the chemical network that could produce phosphine in conditions that aren't like our laboratory? So I think the authors tried to address both of those, but I think that there's room for skepticism. Nevertheless, they should have announced what they found, because you want other people looking at it. You want other people trying to do additional observations to verify or negate.
Mm-hmm. I had on also, it was the just announced, it was the 24th anniversary of the passing of Carl Sagan. This year I've had on Andrewian and Sasha Sagan, the first mother-daughter combo on the Into the Impossible podcast. So that was quite a treat. And everyone was sharing their recollections of Carl Sagan. So I'd be remiss if I didn't ask you about your recollections of Carl and working together, of course, as you guys did. And then we'll take some questions from the audience, and I'll talk to you as long. I know you've got a hard break at 12 o'clock. But what are your recollections of Carl Sagan? What did he mean to you personally and to science in general?
Well, Carl was a spectacular communicator. He had the ability to get an audience fired up and enthused and seeing the world through his eyes, right? Well, I had some really personal relationships with Carl. So I was undergoing treatment for breast cancer while Carl was doing his second round of treatment for his cancer. And so that was a bond. I mean, it's a strange bond, but we talked about how mortal we felt and how difficult it was to tolerate these poisons that you were ingesting. He had much earlier, Carl, who was on our board of trustees at the SETI Institute, Carl had some surgery or exploratory surgery, actually, to figure out why he was bleeding out. It was a rupture of an old scar in his esophagus. And after that experience, Carl picked up a little bit of a King Carl attitude that irked me, right? Because, he understood how little time any of us have and how important it is to make use of it. But to treat secretaries or support staff in a way that says, I'm more important than you are, right? It really irked me. But prior to that, Carl had been a real inspiration. And I was back at Cornell and went to a cocktail party at Carl's house. And he and Annie took me aside and they said, Carl's writing a science fiction novel. And I said, oh, I know. The New York Times just told us what kind of an advance he got, and we're all so jealous. And so Anne said, well, you may think that you recognize someone in the book, but I think you'll like her. And I said, oh, come on. Just make sure that she doesn't eat ice cream cones for lunch, because that was something that I did at the time. And I got teased a lot about it, and people made all kinds of funny remarks about that. And so, okay, then Carl sent me a pre-publication copy of Contact, and I read it, and I'm going, wait, how does Carl know this, right? That's me. How does he know this? And it turns out that I'm just absolutely prototypical of women my age who ended up entering a male-dominated science or engineering career. And after I got my PhD, I went to a meeting in Washington, D.C., sponsored by, I think it was the American Institute of Women in Science. AWIS, whatever that is. And I walked into a room full of 80 women, bright, incredibly curious and intelligent women. And I'd never done that. I was always walking into a room full of men, and often I was the only female. So I met these women, and it was huge. It was life-changing for me, right? And we sat around and we did this kind of amateur psychology. How we were trying to figure out how we made it through a leaky pipeline when so many others had dripped out. And a couple of things that surprised me. A really statistically significant majority of us had been influenced by our dads when we were young. Our fathers were our universe. And then our dads had died while we were young. And it was horrible. But in terms of the impact, is we all learned this important lesson about carpe diem, right? So if I didn't ask my dad a question today, I always figured he was going to be there tomorrow to answer it. And then I learned, no, you can't count on that. So you really do have to take advantage of opportunities when they come along. And so we had all learned that at an early age, and it allowed us to seize opportunities when they showed up. And the other thing was that we were all competitive, right? But back then, it was so early, it was pre-Title IX. So we wanted to compete, and there were no women's sports that you could compete in high school. But the one thing you could compete for was being a cheerleader or being a baton twirler, a drum majorette. And so an unexpectedly large number of us had been cheerleaders or drum majorettes in our high school careers. So there was a little study that was written up after this meeting, and talking to Carl one day on the phone, I was telling him about this, and I sent him that report. And that's where he got, I think, a lot of the characteristics of the female protagonist.
Wow, yeah, he was certainly a titan and had a huge influence on me, and not only because, let's see if I can find it. We got to get one of you, but I've been using this guy a lot lately. This is, of course, none other than my Carl Sagan sock puppet, finger puppet. But and I hope to get one of you made up, commissioned by the Unemployed Philosophers Guild. So that's the only plug I'm going to do. Actually, I'm going to do another plug if you'll bear with me for a second. Thank everybody for tuning into the Into the Impossible podcast. It's such a treat to have Jill Tarter, just to have a little break here. Jill is, of course, the subject of the book Making Contact. Here's a picture of that book. cover by our mutual friend Sarah Scholes, who wrote that book, and she was a guest this past summer on the Into the Impossible podcast. As you know, Jill, carpal tunnel syndrome is one of the number one reasons that academics don't write papers. So I want everybody to take a break and stretch your finger and push the subscribe button, the like button, leave a comment, leave a thumbs up if you think that aliens are real and that ET is out there somewhere. That will help the show immensely to attract great, talented guests like Jill Tarter. Jill, as you know, this is the 60th anniversary of SETI in some sense. The Drake equation, and I believe it was Project Ozma, is about that vintage. I want to ask you, getting a question, what is from a person, a user by the name of Stock Investor? I wonder if that's what his parents named him. But anyway, Stock Investor asked me to ask you, is there anything that happened at SETI during your tenure there as you're the Bernard Oliver Chair, and did anything happen there that the public didn't find out about that you can talk about?
There are no conspiracies, right?
Yeah.
There's nothing hidden. We did have, back a long time ago, I think it was 97, 98, we did have a false positive that kept us going for more than a day. And indeed, it was a really good case because it showed us that it's impossible to keep a secret. Right? We eventually figured out that the signal that we were getting was from the SOHO spacecraft in orbit around the sun. But before we got to that conclusion, Seth Shostak and my colleagues at the SETI Institute, I was at the observatory, were getting calls from the media saying, here's something interesting is going on. You want to talk about it? And fortunately, Seth said, no, not yet. Let us work on this for a bit. But nobody had called up the newspaper to tell them about this, but it did, in fact, leak out and made us very conscious of the fact that it's going to be hard to follow this protocol that we've established, which wants us to confirm and get an independent confirmation, if possible, of a signal before we tell the world.
And actually, some people have suggested, I'm talking with David Brin over the weekend, who's listening in the chat room. He says hello to you, watching you. Hi, David. Hi, everybody out there. Thank you for tuning in. I want to point out that David was sort of suggesting, one possibility is that it could be a hack, right? The signal, Proxima Centauri signal. Do you have protocols against that, in addition to not notifying the media before passing certain tests? But do you have protocols against hacking?
Well, we have been hacked in the past. It was pretty obvious, but nevertheless, it caused us to spend additional telescope time trying to track down something. That is actually the reason for this independent confirmation that we claim as a gold standard, because it's going to be hard for someone to do a hack that hacks two different telescopes when you don't necessarily know what the second telescope is going to be for that independent confirmation. So that's one reason that's one of our requirements. We take hacking. I think that we're an attractive target.
Yeah. This summer I had on David Kaiser, and earlier in the year Paul Davies, who wrote a book called The Eerie Silence. And as we come up on the 60th anniversary, and it's the 10th anniversary since Paul Davies' book, The Eerie Silence, what stock do you put into the evidence or lack thereof for potential, not intelligent life, but life forms, a shadow biosphere, or maybe even intelligent in the form of these lurkers that he and the Benford boys and even David Brin have speculated about?
They're all interesting speculations. There are not yet any data to corroborate. So, in some sense, although 60 years seems like a long time for humans, it's a very short time for the cosmos. And if you think about the nine-dimensional haystack that we're trying to search through for this needle that we prize, frequencies, directions on the sky, modulations, polarization, sensitivity, all of this stuff. And I did an exercise when SETI turned 50, right? And I said, okay, what's the range of each of these parameters that we might need to search in order to find evidence. And then I made a 9-dimensional volume, not sophisticated, but just multiplied all those volumes together. And I said, all right, this 9-dimensional search space, I'm going to set the volume of this search space equal to the volume of all the world's oceans. And then ask the question, how much of the oceans have we searched, as a way to make an analogy. Turned out at age 50, we'd searched one glass of the ocean. By 10 years later, it was more like a small hot tub. So we're getting better, we're getting bigger, and exponentially fast.
Yeah.
But, if you're looking to answer the question, are there any fish in the ocean? And you dip a glass into the ocean and look at what comes out, and you don't see any fish, you're not going to conclude, I don't think, that there are no fish in the ocean, but you're going to conclude that you need a bigger glass or more of them, right? You haven't searched very hard. And so I don't think we should be surprised that after 60 years we haven't found any evidence, even if life and technology out there is abundant. Right? There's the last sentence of the initial 1959 Cocconi and Morrison paper says something that's very wise. It says, probability of success is difficult to estimate, but if you never search, chance of success is 0.
Yeah.
And that's the way I look at it.
Yeah, the great SETI researcher Wayne Gretzky said, "You miss every shot you don't take." I think that's the same kind of sentiment that you're expressing. Yes, I remember back in 2001. Actually, in 2000, I was a postdoc at Stanford, and I've conveyed this to you that I wouldn't be sitting here, at least at UC San Diego, in this branch of the wave function in the many worlds interpretation, were it not for you, as I describe in my book, that you came to Stanford to give a wonderful colloquium. I begged my friends and the faculty there to let me come to dinner with Jill. She's my hero, and I eventually connived my way into it. But through a torturous series of events, I ended up getting fired after that. But that's not a big deal. We can postpone that branch of the wave function for some other time. I'm getting questions that people are curious about this kind of notion of searching and the 9-dimensional playing field like you talked about. Maybe you can explain what that is and how looking in other wave bands that were really just on the horizon back in 2000 when I first met you, that are now becoming more popular, including my close colleague and friend Shelley Wright, who's a professor at UC San Diego here with me, are looking in different wavelengths. Does that add to this multidimensional haystack? And first of all, what does that haystack mean?
Okay, so let me enumerate on my fingers so I may make sure I get 9. So,
unless you're an alien, you'll get 8.
Right. So there are 3 dimensions in space that we need to explore. There's a time dimension, right? There's the whole question of frequency or wavelength. Where should we be looking in the electromagnetic spectrum, assuming that the right thing to be looking for is a signal? There's modulation. Is there information on that signal? How is it encoded, and how will that affect the kinds of detectors that we need to build? And lastly, how sensitive do we have to be? Because we don't know how powerful a transmitter might be or how far away it is. And so those are the 9 dimensions that we need to look through, even if we've made the right assumption that it's an electromagnetic signal we should be looking for. There have been some interesting speculations in science fiction about information being encoded on gravitational waves, on other forms of communication possibilities, other particles that go between stars. We have reasons for favoring the electromagnetic spectrum, but those reasons are not necessarily absolute. They have to do with the physics that we currently understand. They have to do with the technology that we have in the 21st century. So, we freely admit that we might be doing an absolutely fantastic job at exactly the wrong search. But until we develop a new technology or some new physics points us in a different direction, we don't know what else to search for.
And if you put on your Bayesian cap, I'm getting a question from a listener, Kuma-san, who's asking, what is it more likely, in your opinion, or based on Bayesian reasoning, would aliens be similar to us in some sense? I've always made the point, I'll make it to you, I made it to Paul Davies and he slapped me around, but I said, we wouldn't be having, these conversations or even this technology if it wasn't for, dinosaurs existing on Earth. And you made a joke in your TED Talk, which I'll put a link to, the dinosaurs didn't have a really good space program. If they did, they might still be here, which I agree with. And the question of, whether or not one can exist, though, as a technological civilization. We exist because of it, because the dinosaurs no longer exist, perhaps. And we certainly owe a lot of our longevity to planets like Jupiter and Saturn that just participated in this grand conjunction from our vantage point. And so without those planets, those gas giants, we might have been bombarded early on during the heavy early bombardment. So what, in your mind, is more likely that there would be another type of intelligent technological life form, as you've often emphasized to me and elsewhere, or that there's, microbial slime, which would be interesting, or phosphine generating, microbes, which would be interesting, but not technological. With that kind of dichotomy, would you expect that aliens are more likely to be like us or more likely to be like bacteria?
Well, from our point of view, in terms of trying to look for technosignatures, doesn't matter, right? They have to have the ability to build some sort of transmitter or to modify their environment in ways that are visible from long distances. Whether they're a colonial entity made up of lots of small microscopic entities, or whether they're big like us with opposable thumbs and the ability to build things. It really doesn't matter, because we're not looking for them precisely. We're looking for the results of their actions, how they use technology.
Right. And there's a book by Adam Frank, I think at Rochester, called Light of the Stars, in which he says that the most promising signature, techno-signature maybe, would be looking for global warming or some greenhouse effect that would show, agriculture is happening, perhaps.
That's hard to do.
It is, yes.
We're beginning to get the technologies to image exoplanets and derive some information from those images. But the brightness contrast in the optical between a planet and its star is 10 to the 10th. Mm-hmm. In the infrared, it's only 10 to the 8th. But it is really difficult to make an image of a dim, small object so close to a very bright star. And we're getting there, and it's really exciting. I mean, that's the only reason I'm bummed about being old, is because it's going to take a while to get those kinds of observing capabilities, and I might not be around to see what we find, and I'm curious.
Yes, I'll ask you about that later on as I come to the end in 15, 20 minutes. But I want to go back to some of your other, you've had this storied career in history of astronomy as one of our pioneering astronomers in many ways, and really being the driving force behind SETI. I can praise you in ways that might make you uncomfortable, but I'd say it to Seth Shostak, and I have said it to him. But I want to ask you, turning back to your original work on objects that, thanks to you, are called brown dwarfs. Do you keep up with that research, the research that you did back in the in the late 70s, for example, or have you just sort of left that to other folks?
Well, I read about it, but it's not something that I've spent any time trying to push forward. Mm-hmm. Yeah, it was fun, and as a thesis topic, my advisor was wondering about what at the time we called missing mass, right? Looking at the velocities of stars at the edges of our galaxy, we concluded that there needed to be more gravitational mass somehow than we could add up by the masses of all the stars and dust and gas. And so what could these be? And the question was, well, it's a different set of physics that determines whether a collapsing cloud of gas gets hot enough at its core to stably burn hydrogen to helium and shine. That's a different set of physics than the physics that determines how many stars of what mass you create when a molecular cloud collapses. And so we were thinking that maybe there are enough tiny, tiny stars that don't have enough mass to burn stably hydrogen to helium. And those might be sitting out there, and they might be responsible for this missing mass. And if so, what would they look like? How would you find them observationally? So that's what I was working on in my thesis. And, you create, actually, it was using bomb codes from Livermore to make the interior model of the star. And then you need to put an atmosphere on the outside to see how the radiation actually gets out and at what rate. But I couldn't, given the atmospheres, the opacity tables of the time, low temperature, low pressure, they were terrible, and I could never make it work. So I could never tell you what color these little things might be. And Edmund Land once said, brown is not a color. So, as opposed to black dwarfs or red dwarfs or infrared dwarfs, we just called them brown dwarfs.
And the name stuck. I was speaking.
Yeah, and there's a lot more missing mass than we once thought, right? That's the whole dark matter.
Right. Yeah, I was speaking last night with Jayant Narlikar, who is a giant of cosmology and worked with Fred Hoyle back in the 60s for his PhD thesis at Cambridge. And, of course, they were the most prominent ardent defenders of the steady state model. And actually, Jayant still believes that at age 88 or so, and that interview will come out on the Dr. Brian Keating YouTube channel and on Into the Impossible podcast. Again, please, everybody, exercise your finger. Buy the book Making Contact by Sarah Scholes. Jill gets 35% of every book sold. No, I'm just kidding. She doesn't get that. But I do want to make an announcement.
But the SETI Institute does get something. So
yes, and I'm actually going to make an announcement. I am going to match any super chat, any donation through YouTube at least, any super chat, I will match 2-to-1 in my annual donation to the SETI Institute. So please do that. If you want to give some money, I will double it because I love the mission that they are doing. They're really the best. I know you spoke disparagingly about cheerleaders, but I act as a cheerleader for SETI Institute because SETI does such great work, not just for looking for extraterrestrial intelligence and so forth, which is one of the most interesting things, if not the most interesting thing besides cosmology that one could study, but because they do so much awesome actual astronomy and scientific outreach. So please give. I will double it at a minimum up to unlimited amounts, although I don't know how much a Norwegian kroner is. Stock Investor, it's his second $100 or 100 Norwegian kroner donation. He asks, or she asks, what does Jill consider the biggest achievements of the SETI program?
I think now in my old philosophical age that our biggest achievement to date has been to make people change their perspective, right? So talking with you, giving lectures, talking to people around the world, and getting them to think seriously about the idea of life beyond Earth, life that would be spectacularly different from us because it evolved and co-evolved in a different planet or in a different way. I think that whole exercise is like holding up a mirror to all of the humans on this planet and saying, look, all of you in that mirror, you're all the same when compared to something else out there. And it trivializes the differences among humans that we sometimes fight wars and kill one another over. And I think it's really important to instill this cosmic perspective because we have all these challenges that we're going to have to solve, and they don't respect national boundaries, right? We're going to have to figure out how to work globally and cooperatively. And I think that if SETI can help people out there have this perspective of being an earthling and behaving that way, I think we can go a long way to making sure that we do have a long future.
That's very good. So now there's a question about.
Of course, the other thing we did to be concrete, right? We built the Allen Telescope Array.
Yes.
So for the first time, we built a large, an array out of a large number of small dishes, right? And proved that that can work, that we now have enough computing capability to combine the signals from all those telescopes in interesting ways. And now, as we go into the future, the square kilometer array, the next generation VLA, they're all going to be built as this large number of small dish concept. And so I'm very proud that we demonstrated that at the SETI Institute and at UC Berkeley that this can work.
Yeah. Oh, great. We're getting a lot of good donations here. Thank you so much. Reminder, I will donate a match 2-to-1 for the SETI Institute. Any amounts donated in the super chat. Or you can also Venmo me at Dr. Brian Keating. If you like, I will double any contributions made today. Jill, I want to ask you, we hear often, as Sarah wrote in her follow-up to the smash hit Making Contact, she wrote a book called They Are Already Here, about why human beings are seeing saucers. So I want to ask about that. Why do we see saucers? Does that interest you? And have there been any credible sightings, to your opinion? These Navy fighter pilots we hear about all the time. Is any of that convincing to you?
Not yet. And I think it's just the 21st century's version of angels and archangels. Right?
How so? What does that mean?
Well, it's what we see. It's what we think about. It's what we project onto sightings of things that we don't understand. I mean, 20 years ago, people were saying that there were all of these UFOs associated with large thunder clouds. And when we got enough, and including pilots flying at high altitudes, and then when we got enough satellites that were looking down at the Earth with enough time resolution, we found out that lightning travels up as well as down, right? So these are now called sprites and elves, and it was a new piece of physics that we discovered. And I think that people see things. They really do see things. I think the problem is the interpretation of those things having to do with spacecraft. That's where we are lacking in evidence.
And yes, I always see things. There was a podcast by David Fravor, who's a Navy fighter pilot, on Lex Friedman, who's got a very popular podcast. Lex is interested in all sorts of things extraterrestrial. But he made this big point about how pilots are, really good at seeing things that are far away and spatial relations. And so I'm a pilot, private pilot, as I know you are as well. Although I don't know if you're still current. I would take you up in a heartbeat. Someday we'll have to do that. But I once got pulled over by a police officer for speeding. And it was right after I passed my test. I thought I was a young Chuck Yeager. May he rest in peace. And I said, well, listen, officer, I'm skilled at hand-eye coordination, and I know all these things. He's like, that's a totally different skill set. And he said, I'm a pilot, and if I have to rely on my hand-eye coordination, I'm going to crash. So I discount these things as well. And yet, I think there's a lot of resistance. There's this gentleman, Mick West. Are you familiar with him, Jill?
No, actually, that's someone that I've not encountered.
He does the debunking. Michael Shermer has helped to popularize some of this as well, as a friend and former guest. But Mick West is doing work to kind of show how you could get the exact same pattern, these so-called tic-tac patterns, etc. Right. So I think it's worth listening to. Lex Friedman's podcast number 122, he mentions this at some point. Let's see, we only have about 15 minutes left. I want to make sure I get all my guests. A reminder, we're talking with my friend and role model and reason I'm here in San Diego, Dr. Jill Tarter, who is joining us. And I want to sort of understand, where is it? Where is the SETI Institute's Allen Telescope Array? Where is that? What is its current status? I know that the Making Contact describes it as sort of a cliffhanger where it's at currently. But how big into the ocean? How many hot tubs per year can we expect to be searching with Allen Telescope?
Well, the Allen Telescope Array is in Northern California, close to Mount Lassen. And so if you are going to visit Lassen National Park, you should come on down the road and stop by and see the Allen Telescope Array. We currently have 42 6-meter dishes. Our initial ambition was to build 350. But, we thought we'd done all the technology development until we started to build. And then we found out there's a lot more to do. And so we ran out of money before we could get to 350. And if you're going to stop somewhere, it seemed to me 42 was the right place, right?
It's a lucky number. You know why? Do you know why it's a lucky number? Not in addition to the Hitchhiker's Guide. It's the most fortuitous number there is.
Oh, right.
That's a groan.
You didn't say
Sorry.
That. Oh, that's a groan. Yes.
I'm a dad. What can I say?
We first began observing in 2007, and right now we're retrofitting the antennas with a new spectacular feed designed in most part by my husband, and that feed allows us to look at more bandwidth at any moment and to have a lower system temperature, so to be able to see fainter sources. And we're in the process of doing that. And again, it's one of these things where we have some funding from Franklin Antonio,
who's here in San Diego.
Yes,
friend of us.
But we don't have all the funding we would like to have, and so it's going a bit slower. It's being used on and off to do SETI observations and also to observe fast radio bursts, right? These mysterious radio sources that are coming from, most of them from extragalactic distances, and trying to understand what the physics is there. So we're not on the air with our standard 24-hour a day, 7-day-a-week SETI observing program, but we're getting there, and looking forward to being back to doing those observations. And it's one of these things, you do it from your bedroom, right? This remotely controlled telescope that works on its own and hopefully doesn't miss any signals and announces to us when there are interesting things that it needs help figuring out.
Is it possible that so what's the status of SETI at Home? Is that no longer active?
Right now it is no longer active. They shut it down earlier this year. There are lots and lots of data, and they need to spend some time understanding what it is that they have detected thus far.
Very good. Yes. Yeah. It was one of the first citizen science campaigns. It was extremely popular. And I think it was almost a victim of its own success in some ways, because it was so powerful. It could occupy a lot of otherwise dead cycles that otherwise well-intentioned corporations like Google and Dropbox would like to be using. So, but hopefully it will be it'll always be hopefully it'll be resuscitated at some point. And I want to congratulate SETI at Home for I think it was 20 years at least that it was started.
Yeah.
So we're coming to the end of the.
We always get asked about SETI at Home, but that actually was a very clever project out of UC Berkeley.
Right. Yeah, that was part of Berkeley. So I want to ask just a couple more questions from the audience. First of all, Willie. I can't pronounce it. I think it's William is asking, is there a protocol if we do detect, if we are successful in kind of having a unambiguous message from an extraterrestrial technological civilization? Is there a protocol to deal with that?
Well, yes, there has been a protocol for a very long time, starting back in the 80s under the auspices of the International Academy of Astronautics and the International Institute of Space Law. We tried to figure out what we should do, and indeed we started this protocol, so-called post-detection protocol, as a way to encourage our Soviet colleagues to have some backing that they should, having decided that what they were seeing was real and potentially an ET signal, to give them the backing that would allow them to tell the world, right? Because it wasn't clear that information would ever get out of the former Soviet Union. And over the years, that protocol has morphed. When we were a NASA project, there was a step in there that described which associate administrator would notify the executive branch, right? So now that we're no longer a NASA project and privately funded, that's left. but it's still basically common sense. So you do everything that you can at the discovery site with what tools you have available there to show that there's really something that you think you're seeing. And then, because of hacking and just to have verification, you go and get an independent confirmation from a telescope that has software you didn't write and hardware you didn't build. And if they can confirm it, then the next step is to tell the world, and what you tell the world depends on the nature of what you're seeing. Because you'd like to have as many different facilities with as many different types of detectors looking at this and trying to figure out what it is. So we do tell the world, but not instantly, because we want to get this independent confirmation.
And then Kuma-san is asking, what is the impact of the loss of our beloved Arecibo radio telescope?
Well, Arecibo was certainly, prior to FAST, in China, Arecibo was our most sensitive telescope. And we, up until 2004, we were fortunate enough to have something like 15 or 20% of time on that telescope to do SETI observations. In 2004, we decided we wanted to be on the air 24/7 and began building our own telescope, the Allen Telescope Array. But Arecibo has some unique characteristics. It has a planetary radar. It has a 2 megawatt transmitter that, with the large dish, has a huge gain and can focus this transmitter onto an asteroid, for example. It can improve the determination of the asteroid's orbit after it's been detected, but it also can actually map the shape of the asteroid. And so that planetary radar is unique. There is a radar at Goldstone on a much smaller telescope, but that's a loss. Sensitive radio astronomy observations of millisecond pulsars as part of a pulsar timing program in the Nanograv project, which involves a lot of observatories around the globe. But Arecibo, when you put that into the mix, really did improve the sensitivity. So yeah, it's sad. But it just shows you how difficult it is to maintain high technology in a very trying environment of humidity and salt.
So thank you. I have a question, a super chat from my good friend Jacob Kuhn, who's been helping out with this live stream. Jacob, thank you so much. $10, which will get turned into $20. Last chance for folks to donate and have the money taken out of this poor state university professor's salary. But I love to do it because SETI Institute deserves every penny, and I am a longtime donor, frequent speaker, and just one of the biggest fans of the SETI Institute. And all that, I have to be honest, is thanks to Jill. Don't say anything, Jill. To Seth, because he'll get jealous and he won't give me that cup of coffee. I'm really waiting for that cup of coffee in 2027. I think he's going to give it to me. But Jacob is asking, are we going to put a telescope on the moon, and will it have any validity or any utility for SETI searches?
Oh, well, we're talking about it, and in particular on the lunar far side, because when you think about all of the orbital assets that we're putting around this planet with lots and lots of transmitters, it's getting pretty radio loud, and we spend more than half of our computing trying to discriminate what we call radio frequency interference from something that actually may be coming from a distant star. So the lunar far side is quiet. We recognized this long ago. I think it was 1974. The Astronomical Union went to the ITU and said, let's create something called the shielded zone, a shielded zone of the moon, in which there will be no transmitters. So we've been thinking about it. Unfortunately, NASA's planning to build a gateway right above, in orbit above that shielded zone of the moon. So we're hoping that we can convince them that as they build this with communications capability, they build it so that there are two frequencies. So at one time, will get to be able to listen at all frequencies uninterfered with. So the challenge is likely to be regolith and how it impacts anything with moving parts. The Apollo astronauts came back into the capsule coated in this dust, and it even got into their lungs. So it's it's hard to work with, but particularly with low frequency receivers, which could in fact have no moving parts, but just be essentially huge dipoles wrapped up in a polyurethane case and pulled out on the lunar surface to expose them. That low frequency is possible from the moon at lower frequencies than we can observe from Earth because of the ionospheric cutoff that we have here. So the lunar far side has a lot going for it. I think it's probably above my capabilities to try and raise the funds for that. So we're going to do that. If we do it, we're going to do it in conjunction with something else that is going to the far side of the moon to create infrastructure.
Well, who knows? You might get a call from a billionaire orbiting around in some satellite in the not too distant future. I hope you do. And I think it's just so amazing the work that you've done, and you're inspiring literally millions of people around the world, Jill, in addition to the way you've inspired me and been a role model to me. Now I want to finish up with the final 3 questions that I ask all my guests, if you're game, before we release each other to our respective telecons. The first one is, I want to ask you if you were to leave an ethical will, not a material will, but an ethical will, which is sort of similar to what Alfred Nobel did, as I describe in Losing the Nobel Prize. He not only endowed, these golden pieces of medallion that I've been stealing off of all my guests who come on who have Nobel Prizes and didn't lose them, they actually won them. But Alfred said the invention or discovery must be for the benefit of humankind. So it was an ethical will plus a material will. I want to ask you, what sort of wisdom would you like to leave for your biological progeny, but also your ideological progeny, which I count myself as one?
I would really like to turn Earthling into a meme, right? I would like everyone to go to their electronic devices and pull up the profiles that describe them and have them write the first thing about themselves is that they're an Earthling. And then I'd like to have them behave that way, to actually internalize this cosmic perspective and behave as global citizens.
Very good. Now, the next question harkens to the name of this podcast I will get to, is Into the Impossible, and that relates to Sir Arthur C. Clarke's famous 3 laws. We'll get there in 1 second. But before we do this, I want to ask you about Arthur C. Clarke. You've surely seen 2001: A Space Odyssey, the movie.
Many times.
Okay.
And the ending is still enigmatic.
Yes. My chagrin always comes when I talk to somebody who's a sci-fi fan. They say, no, I've never seen the movie. But anyway, I'm glad that you've seen it. You'll recall there are very many sort of interesting kind of forecasts for the future. But one of them kind of goes into the future really far, when the primates on the savanna of Africa and later on the surface of the moon or in space, the characters encounter this monolith, this menacing black obelisk thing that seems to be like a time capsule meant to last for 1 billion years. And I always ask my guests, what would you put on a time capsule that you knew would last for 1 billion years? And I actually asked your friend Ann Drury this, and she said, I did it. I put my brainwaves on the Voyager golden disk and sent it out for 4 billion years, NASA told her. But I want to ask you, Jill, what would you put on a monolith? What sort of fact about the universe would you think most deserves projection into the future?
I would say that we were we were here, we were many, then perhaps not so many, but all of us were curious. And that's what humanity is about, being curious and trying to understand our place in the cosmos.
Very nice. And the final question before we both break for our telecons. I always thought that astronomers would be on telescopes, but we're mostly on telecons. Is that not right?
Indeed.
So the last one allows us to zoom, no pun intended, backwards in time. So Arthur C. Clarke had these 3 laws. The first one, which we open our podcast up with, is his actual voice saying the following: any sufficiently advanced technology is indistinguishable from magic. His second law is that for every expert, there's an equal and opposite expert. And his third law is the only way of discovering the limits of the possible is to venture a little way past them into the impossible. And that's the origin of the name of this podcast. I want to ask you sort of advice to your former self. What aspect of life, what mysterious feature of your future would you like to demystify and give advice to your former self to have the courage to go into the impossible?
Yeah, I would say to be bolder than I was in terms of ignoring the conflation of UFOs and little green men with SETI, and to have the conviction that this scientific exploration is really worth doing. It may be multi-generational, so we have to get clever about how we fund it generation upon generation. And just don't listen to them, right? Do your thing and do it scientifically, do it rigorously. Don't ever regret anything that you've done or that you've written, and just go for it and think out of the box, right? So electromagnetic radiation, how, and encoding. Well, there's something that we're beginning to know about now that we didn't know when I was in graduate school, called quantized photon angular momentum, which might be a way of encoding information. And so, just keep going. Put your head down and ignore the noise, and just keep doing what you think is worthwhile.
Well, Jill, I want to thank you so much for going into the impossible. I want to ask my all my listeners and friends out there in cyberspace to thank you for your support. Please do subscribe to the podcast. Subscribe to wherever you get them. Subscribe to my email list, which you can get on briankeating.com, and you'll get a huge ebook that I put together from my conversations with leading astronomers replicating the Great Debate, because that's 100 years old this year. In addition to the Hubble Space Telescope and the International Space Station are 20 and 30 years reverse chrono. Anyway, I screwed it up. But Jill, we love you. We're so honored that you came on the show. Thank you for being a friend to me personally and inspiration to millions around the world. And I wish you the best of health and luck in 2021.
Thank you, Brian. It's been fun. I've never been thanked for getting somebody fired before.
That is provocative and cryptic, but read the book. You'll find out more. And Jill, have a wonderful rest of your year and next year as well. Take care, everybody. Bye-bye. Bye, Jill.
Bye.
Everybody, thank you for joining on the Into the Impossible podcast. As I said, please exercise your fingers regularly. Click subscribe, hit the notification bell, and leave a comment on what Jill and SETI means to you and what you'd like to see them do. I will take a few more donations. It looks like we got over $150, so hopefully they'll be getting a nice bonus, and maybe they can use that to upgrade their radio receiver technology. But for now, I want to just let you know we've got some great guests coming up. As I mentioned, Giant Narlikar, a giant of cosmology, one of the leading figures of alternative cosmology, the steady state. What do we have to learn from that? You'll find out very soon. Lord Martin Rees is on the show. He reads my horoscope and tells me what's coming up in 2021, the mysteries of the heavens. And lastly, not leastly, we have Ray Weiss, who's the godfather of astronomical telescopes using gravity and microwaves, as he's played a huge role. Did a wonderful interview with him. I know you're going to enjoy it. And we're hopefully getting really cool guests as well in the new year. John Preskill. Going to have Deepak Chopra. Now, before you get mad at me, it's not only Deepak Chopra. We're going to have Frank Wilczek, hopefully, with Deepak Chopra, Leonard Mlodinow as well. We're going to have hopefully a live stream that we can all kind of ask questions and do so, as we love to do, with humility, with honor, and with dignity and respect of all these guests, because everybody has something to learn. And as Mahatma Gandhi said, the only way to go into the impossible, no, the only way to succeed is to subdue your ego and act more humbly than the dust. And as you know, dust is the villain of losing the Nobel Prize. Anyway, guys, this has been fun. I'm getting loopy. It's the end of the year. It's been an awesome year. There's still more live streams to come, as I said, so stay tuned this week. I'm not signing off for the year yet. I'll let you know when that happens. It'll be midnight on December 31st. Take care, everybody. I got to go to my telecon. I dropped my mouse, but we'll get out of here somehow or another. Take care, everybody. Bye-bye.